In this video, we'll be looking into the fifth module of software testing subject. There are two chapters here. First one being the system testing and interaction testing. So firstly, we'll start with interaction testing because the topics here are pretty limited and easy scoring topics also. So starting from the interaction testing. So interactions in software system are common and can lead to many faults. So as and when the software system interacts with the software interacts with the system, there are n number of errors which can occur here. So which are challenging to detect and test. So the interaction could be between the system constructs. So it could be any action, data, event, port, or threads. So be it, for example, if we consider our SATM system, interaction between a user to a system, or through the card which he is inserting, or the button which he has pressed. So all those come under interaction scenarios. So adding location as an attribute to these can help in understanding the interactions better. So while dealing about the interaction testing, two things are main here. One is the location and the other one is the session management, the time in which the interaction is happening. Okay, so we'll look into it further. Here we have the ground rules for interaction. So the first one is thread duration. That is, I told the time it takes between the execution, that is from the start time to the end time. By having the time, by knowing the time, it helps us to understand the interactions better. Then we have the single processor value rule. So here two threads cannot execute simultaneously on a single processor. That is, time sharing creates an illusion of similarity. Okay. Then we have the event duration. Event duration is amount of time taken by the event. So it is again similar to thread duration. In thread duration, it is the time taken by the thread to execute, and in event, it is about event. Then we have the simultaneous event. Simultaneous event means two events cannot occur together. Two events cannot occur together in a single processor, but then two events can occur together in a multiple processors simultaneously. Then we have the output event. Output event means in a single processor, two output events cannot begin at the same time, because one event would be depending on certain resources, or there will be some threads which will be helping for this event, this output execution. So when I am accessing, when I'm making another event, another output to execute, it is not possible because this particular resource is already being utilized. So this was about the ground rules for interaction. Then we have the taxonomy of interaction. Taxonomy of interaction has, the major thing is interactions are time dependent and not whether they occur in single or multiple processors. So the main thing here is time and position, as I said earlier. So here we have four types of interactions. So there are four types. So the first one is static interaction, single processor. So interactions that occur within the regard of time with a single processor can be termed as static interaction in a single processor. And static interaction in multiple processor andre time dependent interactions occurring in multiple processors. Then we have dynamic interaction in single processor. Dynamic interactions andre, sorry, here static interactions means it is time independent, whereas coming to dynamic, they are time dependent. Okay, so dynamic interactions in a single processor means time dependent interactions with a single processor. Then we have multiple processor. So again, time dependent interactions occurring across multiple processors. We'll look into this further one by one. But as of now, if they ask taxonomy of interaction, make sure you write these 4 points and make sure you write about the time and position importance and explain these in 3 or 4 lines of each. Okay, moving further. So this topic is again important one. It was asked in internals for 10 marks. So it might be asked in externals also. First topic we have here is interaction. So interaction in terms of our interaction testing. Okay, so in context of software systems, it refers to the interplay between different components or threads or data elements within a system. So the interaction happening between different threads, different functionalities could be termed as interaction. So these interaction could include complexities, essentially when they lead to unexpected faults. So there are complexities which arise due to such interactions. So when two threads or two data elements or two components interact, there could be chances of high complexity or there could be debugging problems or wastage of resources or anything could happen. So they come under unexpected faults. So identifying and testing these is important because they can reveal the faults that are not apparent in isolated components. So when I'm testing a particular functionality separate, so identifying and testing these is important because they can reveal faults that are not apparent in isolated components. That is when in let's consider the SATM system. In SATM system, when I'm testing the pin part, okay, I am testing if the buttons, the numbering buttons which are present there are working properly or not. So working of those buttons is one component, but then when I'm interacting it or combining it with accessing the value, the valid input, and then further processing it. So when I press the buttons, no, the details may be depicted properly into the system background, but then those details, if I press 4 digits, it has to be correct value ಅಂತ ನಮ್ಗೆ ಗೊತ್ತಾಗ್ಬೇಕು ತಾನೆ. ಸೊ ಅದು ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ we should club those two things and then perform testing here. So yeah, that's what they have told. Identifying and testing this is important because they can reveal faults that are not apparent in isolated components but become evident when the system components interact. So that's what they have told here. Example, where different threads interact with share account balance. So the order of execution can lead to different outcomes. So let's consider two transactions. First transaction, I'm adding, consider two transactions. T1, I am depositing $30, and T2, I am withdrawing $30. The balance was $30 initially. So now the sequence in which the execution happens also depends here. So if T1 is happening before T2, if T1 is happening before T2, then the balance would be $60, and withdrawing $30 means I'll be left out with $30. Then if T2 is happening before T1, so let's write 10 here, okay. So 30 plus 30, 60, 60 minus 10, 50 here. Now coming to here, T2 is happening before T1. T2 is happening before T1 means, firstly, out of $30, I have taken out $10. So I have $20 here. So in $20 again, depositing $30. So I'll get $50. But then the first step when we performed, here it was $60. But then the first time when we did first execution of T1, I had $60 in my balance. But then first execution of T2, I had $20. So again, if I don't perform the next operation and withdraw the money, then it is not proper, right? It is not obeying, it is not same, equal. So that's what they have told here, making it essential to test various interaction scenarios to ensure system reliability. Next, firstly, we looked into what interaction is. So make sure we write the proper definition of interaction, why is it important, and giving an example. Okay. Next, we have composition. So composition is testing how components work together after they are interacted is crucial to ensure system behaves as expected in the real world scenario. So here we will be testing the system, okay. We'll be testing the system, we'll be testing the components, how they work together when they are integrated. So by understanding when they are integrated, how will they function, it helps us to deduce whether our components are working according to what we had aimed. So when I inserted a card and when I entered the pin, money had to come, or when I selected withdrawal, this transaction money was supposed to come, right? So when I'm combining all these different threads, then the expected output should happen properly. In order to test that, we'll be making use of composition. Okay. So if we compose thread like withdraw $40 and deposit $30, we need to see how these actions interact. The sequence and timing of these actions could lead to different states of account balance, which must be tested. So that's what I told. So we can say that composition is pretty essential in integration testing, where individual components that have been tested in isolation are combined here and we check it further. So this was about interaction, composition. Next we have is the determinism. Next we have is determinism. So for a given set of inputs, the system will always produce the same output. So if the system is always producing the same output, then those items could be called as, or that particular system could be called as deterministic system. And if the output which is being produced is different, then it is termed as non-deterministic system. So when I perform testing on a deterministic system, I'll be knowing that the same output would be generated. In that case, that sort of testing is called as deterministic testing. And opposite to that is when I'm performing a testing, the testing becomes challenging because the same test can produce different results. So this requires multiple test runs, and we have to carefully analyze the outcomes. So that is called as non-deterministic testing. So in deterministic testing, testing is more straightforward because expected output is consistent, whereas in non-deterministic, it is a challenge. So the previous example only which we have seen, attempt to withdraw $60 is one transaction, and deposit of $30 is one transaction. So the output of T2 depends on whether T3 has executed before or before T2 checks the balance or not. So depending on this scenario, see, suppose if T3 executes first, no, T2 will succeed in withdrawing $60. If not, T2 will fail because there is insufficient amount in the account, right? So yeah, so that was about determinism. So if they ask these three things, no, make sure you write them with proper explanation. Then why is it important, and then we have example here also. Next, moving forward, we have client and server based testing. So client and server based testing under interaction testing is again a pretty important topic. This could be asked for 10 marks, guys. So if not 10, it could be asked for 5 marks for sure. So understanding it here. So client and server, we know what client is and what server is. So client requests like a particular service or some data from the internet or from the website, and server has to provide those details to the client back, right? So client will request, and through the internet server, and server will fetch the data and give it back to the client through response. So here, client server interaction. So client requests resources and server gives them. So they can include data exchanges, API calls, user authentication, session management, and data retrieval. So types of interactions. So if we look at the types of interactions here, first one we have is request response cycle. So request response cycle early, the client will raise a request, and depending on that request, server has to look into that request and perform required operations and then give the response back. After receiving the response, if client is not satisfied, he wants some more data, then again he'll raise a request. Again the server has to satisfy, server has to fetch the data, and then again give the response. So this cycle of request and response could be termed as request response cycle. So this is one type of interaction. Then we have is concurrency handling. Concurrency handling means many clients are trying to access the data at the same time. Many clients are asking the server to send the data. At this time, the server has to carefully make sure that deadlock condition should not occur here. So there are further many ways to deal with it. So that's what concurrency handling speaks of. Then we have state management. State management is to validate how the server maintains and updates the session states through across different client interactions, right? So when this client is accessing some data and the server is like performing the operation, the server is being used, so another client cannot access it. Here the state is being used state. So that's what it means, state management. Moving further, looking into the key testing scenarios. Looking at the key testing scenarios, first one is data consistency. So we have to ensure that the data remain consistent throughout the interaction. If the server is sending AB, then the client should also receive AB only. If he's getting BA, then there is some fault. Then we have error handling. Error handling is to test how the system handles unexpected inputs, server downtime, or any network failure is happening. How will it deal? Then we have security. So it is pretty essential to make sure that the data which is being sent from the client and server is safe. So there are no any cyber threats happening or anything of such sort. So this was about the key testing scenarios. Moving further, we have the tools and techniques. Speaking of the tools and techniques, those are the mediums through which the client server testing could be performed. So the first one we have is simulation of multiple clients. Simulation of multiple clients means we can make sure that multiple clients are trying to access the data from the server. So when we do this, we can perform like if the server is working properly or not. Then we have monitoring and logging. So we can implement detailed logging on both client and server sides and trace how the interaction flow is happening. Then we have the latency testing. So in latency testing, we are measuring the time, how much time it is taking to get executed. So this was about the tools and techniques. Looking at an example for the client server testing, we can write bank application. That is, client requests account balance update, and the server retrieves data from database, processes and sends it back to the client. So here interaction testing would verify if this flow works properly under different conditions such as a peak load at the peak time or network delay or network failure or any of such situations. So this was about client server testing. Let's move further. We have our system testing topic here. That is the first chapter. So in first chapter, let's understand what system testing is initially. So system testing is the final phase of testing. If we look at the SDLC pattern, it is the last stage, right? So we test the entire system as whole here. So unlike unit or integration testing, system testing focuses on evaluating the system's behavior on based of users' expectations. So depending on users' expectations, users' perspective, the system would be tested as a particular element, as a whole element. Okay. So back then in SATM, if I consider, I had performed testing for entering the inputs. There was a separate testing for the terminal screens. Then there was separate testing for managing the sessions and all of that. But then when I combine all these and term it as a SATM system and perform system testing on that, it is called as system testing. Okay. So here I'm evaluating the entire behavior of SATM. Okay. Not just a particular component or a particular unit. Okay, so the purpose of system testing is to confirm that system is behaving according to the user's expectations, not just the specification. So specification, yeah. So the system has to obey the specifications, but then along with that, the user's expectations are also to be met. Okay. So from users' expectations, that is from users' perspective, testing a product that I want to buy, make sure it works well and meets all my needs. So when I'm looking at it from a user's perspective, it's like testing a product that I want to buy. That is, I'll see if it works well or if it meets all my requirements or not. Anta. I won't check only the camera when I'm buying a phone, right? I'll make sure that camera, battery, and all other features are working properly. So that's what entire system I'm considering. Okay. Moving on further, we have a topic of threads and system testing. So threads is a scenario of normal usage. So threads have different definitions. When you refer the textbook, you'll understand. So I've written all those definitions here. Thread is a scenario of normal usage, or it could be a system level test case, or it could be a stimulus response pair, or the behavior that results from a sequence of system level inputs, or it could be termed as sequence of transition in a state machine description of system, or it could also be called as sequence of path or atom system functions. So these are all the basic definitions of the threads. So moving on further, looking at levels of threads. First we have is the unit level. So unit level means they are small, detailed threads will be there, and individual functions would be performed in this units. Then we have integration. Integration means when I'm combining different units together and then testing. Then I have the system level. In system level, these are the high level sequences comprising of the entire system. The entire integration along with the system is combined here. Next we have system level. So we have discussed system level. So in our SATM system, thread possibilities are looking at what are the possible examples of threads. Okay. So we have the digital entry. Digital entry andre I am entering some number. I am entering my pin number into the screen. No, I'm pressing the keypad buttons and then I'm entering the value. So this could be one of the thread. Okay, thread. One small operation. Then I have pin entry. Pin entry is specifically entering the pin number and then getting responses from the ATM. Then I have simple transaction. Simple transaction means I put the card first and then I entered the pin first. Then I'm selecting the transaction. After selecting the transaction is getting completed. So this is a simple transaction. Right from the start to the end, everything is being defined here. And I have the ATM session. ATM session involves multiple transactions in one session. So at this level, system testing checks how different threads interact. Okay, so an ATM session, not just deposit or withdrawing the money, there could be other operations also happening simultaneously. So that comes under ATM sessions. So we started from the simplest explanation for thread and we understood it till the complex part. Okay, so make sure that if they ask what are the explain threads in system testing and thread possibilities with an example, make sure that you write this part. Then we have atomic system functions. So there's a small topic called atomic system functions. So ASF are small basic actions that system performs in response to an input, like inserting a card at a ATM. So these are the minute like actions or operations which are performing. Okay, so these functions have smallest meaningful actions at each level and can't be further explained. Okay, so if I have to take the SATM example, inserting a ATM card in ASF, inserting a ATM card is ASF example. So that is, I've just inserted the ATM card. I cannot further split it. Okay, so in ATM card ಹಾಕೋದಿತ್ತು ಅಷ್ಟೇ ಮುಗೀತು, ಅದೊಂದೇ. That is one particular tiny operation or action which I'm performing. So that was about ASFs. Moving on further, we have basic concepts of like we have basic concepts of requirement specification. So in this basic concepts of required specification, we have 5 topics. Okay, so this can again be asked for 10 marks. Here we need to like explain each and every topic. So first one is data. Data means it has the information about the, like, what is the system made up of, what are the variables. It stores the information. It has all the details about what are the variables, what are the files being used, and further many details about the requirements about the system. Then I have actions. Actions are what are the operations which are being performed after taking the data. So once I consider the data, I have to perform certain operation, right? So this operation is called as actions. Okay, so for example, collecting the pin was data here. Pin collection was data here, and action would be to tell if the pin is valid or invalid. Then I have devices. Devices means the hardware components which facilitate the actions to be performed. That is the SATM system here. Then events. Events are like the system level inputs or outputs that can occur on the port devices. So this could be discrete or continuous. Events andre when I'm pressing a button in the keypad. So it is one type of event. Then thread is a sequence of actions that represent a flow through the system, right? So here it could be I entered the first, I performed the event of pressing the button. Then I entered the data. Then after that, a particular action was performed, and all this happened inside the device. So that is what thread speaks of. So this was about the basic concepts of requirement specifications. So guys, I have explained this with respect to the SATM system. Firstly, I would say that give the introduction part of these topics in general sense, general terms. Okay, and after that you can be like, for SATM system anta ishtella baribodu. Okay na. Then we have relationships and modeling. So in relationships and modeling, data, actions and events are interrelated. So often many to many relationships happen here. So actions involve data, and events and threads combines in multiple actions. So here we have 3 models further. So first one is the structural model. Structural model is, by definition, we can understand it depends on the structure of the system or of the model which we are considering. Then coming to contextual model. Contextual model is, here we focus on what the role or what is the focus on system devices. And coming to structural, it is about the hardware and what is the interface and all of that. Speaking of behavior is like what are the actions being performed, what is the events, how will it react, what is the flow of execution and all of that. So we have understood the basic relationship between all these basic components firstly, and then we looked into the types of models. So it could be structural model or contextual model or behavioral model. Moving on further, we have the structural strategies for thread testing. Again guys, this is a 10-mark question, so pretty important, make sure you don't miss it out. Firstly, we have is the bottom-up threads. Bottom-up threads andre testing begins with lower level components. So we have seen what bottom-up testing is. So if I consider a decomposition tree for our SATM problem, it is not this exactly, but then we are covering each and every unit testing it, moving further, and then integrating the entire thing, and moving further, and finally we take the entire SATM system as the system and perform the system testing here. So this is what we have understood in the fourth module, right? So it is the same. Okay, so bottom-up thread testing begins with lower level components or individual units. Then we integrate and test these components as they interact together. Yeah, that's what I told. So the approach, if we see, first I start by ensuring that the functionality of the ASFs, the atomic system functions. So I consider that the minute functions which I'm starting, so this function which I'm starting, no, this has to be ASF. That is, it should not be further split. Okay, it should be very simple and very basic operation happening. Okay, so assuming that the lowest level which I've selected is ASF, I move further. That is, I gradually build upon the test interactions between these components and then integrating them to form a complex threads. So yeah, if we look at the example, we test individual actions like pin entry before combining them in full ATM transaction system. Yeah, again, as I explained. Next I have is the nodes and edges coverage matrices. So in node coverage, we keep a measure on how many of the individual nodes here refer to the states. Okay, how many of the individual nodes in a state, machine or flowchart are executed. So during the testing, our goal is to ensure that each state in a state machine is tested at least once. So looking at this diagram, we have to ensure that each of the node here should be tested at least once. So by making sure that each of the node is tested at least once, we will come under node coverage criteria. Okay, example. So nodes are pin entry, awaiting the condition or transaction being processed, and all of that. Then we have the edge coverage. Edge coverage and between two nodes, whatever the flow, whatever are the medium for performing the flow of the transaction comes under edge. Okay, so meaning how many transactions between nodes are executed during the testing. Yeah, that's what I told. We have to see that each transaction between the state is executed at least once. So not just the nodes, even the transactions should happen at least once. So if I consider a node that is to enter the ATM card, enter the card, that is one node, and then entering the pin is a second node. So these two nodes have made sure that they are tested at least once. Now when I enter the card, it has to activate the software such that it takes the pin inside. So when I activate this has to initiate that this is working on, or this is the next step. So this transaction between these two is taken care by the edge coverage. So that is pin entry and transaction processing among those two. Okay, next, moving on further, we have the functional strategies for thread testing. So again, this is again a 10-mark question, guys. You might be thinking for each and every question I'm telling 10 marks, but then these are all the topics which are present in fifth module. Yeah, I have skipped few topics because they were pretty difficult to understand and they may not be asked in exam. Okay, so concentrating on those topics which have some weightage, we'll be looking into it. So all these questions that I've covered have been asked in our internal exams, and that's how I am specifying the marks also here. So first one we have is the event based thread testing. So our objective is to verify that different scenarios of the port inputs. Port input means it could be any sort of input. Okay, port here could be the interaction between the hardware to the user. Okay, so verify different state scenarios of the port input events and their handling by the system. So here we have 5 coverage matrices. So let's look into them here. So the first one, we have to write all these, okay, in exam. So first one is P11 Hold1. So here it is, each port input event occurs. So each port input event occurs means we have to verify that each type of input event, like if I press a button, that is one port input, right? I'm enabling or providing some data to the system or entering some data by pressing the button. Okay, all those are events which are happening. They have to be processed at least once. So we have to make sure that every key on the keyboard is recognized by the system. I should press all the keys and then test once. That is first statement what it says. Next, we have common sequences of port input event occurs. That is, I have to validate the what is the sequence of keystrokes that represent a common user action. That is, if I press 332, that is one sequence, right? So this sequence should be handled properly. Common sequences of port input event occurs. Then I have event port input event on every relevant data context. That is, when I press a button, it should be tested across different screens and or different modes whichever are present. That is, in transaction also, in withdrawal also, the buttons should work properly. In if I'm withdrawal also, it should work properly. If I'm doing any other operation also, it should work properly. Next, I have all inappropriate input events occur in a given context. All inappropriate event means I have to test what happens if I enter a wrong key, key. Okay, so if my pin is 3312 and if I'm pressing 3331 in first stage, 3311 if I press in first stage, that is while entering the pin, one output would be generated. Okay, after that, when I'm pressing the amount to be withdrawn, again I'm pressing 3311. So if my account balance is $300 and I'm pressing 3311, that is way beyond that. So we have to test what is the possible output, what is the output which would be generated for such invalid cases. Then I have all possible inputs, all possible input events occur in the given context. That is, I have to make sure that my conditions are satisfied. Whatever the preconditions have been set for my SATM system should be satisfied, and within that range, I should perform different testings. Okay, so that's what it means. That is, I have to verify all the keys are functional and handled correctly during the while I am entering the pin into the system. So this was about the event-based testing. So depending on the events and the ports, I'm performing testing here. Next, I have port-based testing. So in port-based testing, my focus is on the interaction of different ports. Here we have the input ports, output ports, and all of that, and the events associated with them. So this helps us to identify what events can occur at each port. That is the test threads that cover both input and output for each port. So looking at here, yeah, so that's it. In port-based testing, there are no metrics. It is just you have to write about it. Okay. Just write few more points how port-based thread testing is important. So depending on what port we are accessing, it should work properly. If not, if it doesn't work properly, then there will be error thrown up. Something you can fill it. Okay. Next, we have data-based thread testing. Data-based thread testing means this will, whatever the data, whatever the pin we enter or whatever the card we enter is considered as data, right? So depending on this data, we should perform the test. We should perform the thread testing. That is, test based on data model of the system. So the first one, matrices and different metrics. We have one is DM1, that is exercise the cardinality of every relationship. Cardinality of every relationship means we have to make sure that if it is 1:1 or 1:n or n:1 or n:n, these are all cardinality ratios, right? So I have to make sure that in my database, all these cardinality ratios have been tested. Okay, so one user can have one user can have one pin, or one user can have one card. One user can have many transactions, not at the same time, but in general. So all those cardinality ratios should be taken care of. Then I have exercise participation of every relation. Participation of every relation means I again know partial participation, complete participation. We have studied it in DBMS. So the same thing here. Then I have functional dependencies. Functional dependencies, again, we know if X is dependent on Y or Y is dependent on X and all of that. So again, this is also a general thing to write, provided that you know all these concepts which we had studied in DBMS. So this was about the functional strategy for thread testing. Okay, moving on further, we have the static interaction in single processor and multiple processor. So yeah, this could be asked separately or this could be clubbed together and asked. So the first topic we have is single processors. Single processors means they have only single processor by definition, we can understand. So in single processors, we have static interactions. Yeah. So in static interactions, we have sequential execution. When we have a single processor and there are a set of a set of threads which need to be executed, all these should happen in sequential manner, right? So they cannot go at once and perform congestion there at the processor, because only one processor is there and only one processor can handle one task at a time, or one problem program or event, anything you can say, right? So they have to follow a sequential execution. Next I have is context switching. Context switching is the processor uses context switching to manage multiple threads depending on, see, we had come across deadlock, right? So we had deadlock concept. So even there it was a single processor, but then context switching was happening there. So if a particular function had a higher priority, then I would keep whatever is being executed aside, and I would call that person inside, or that particular task inside, and perform that particular task. So that is what context switching is similar. You can draw the similarities that way. Then we have resource sharing. Resource sharing is, since only one process is executed at a given time, the resources like CPU, memory, and all the other resources are shared in a controlled manner. So the interactions are often simple, but can be less efficient if context switching is happening among them. So if I had to print I had to print the output on the screen for a particular task, it is happening. That is, the screen is being, the monitor, the memory, and the CPU are being utilized by this particular task. And out of nowhere, one more task comes, and he's like, or this task is like, I have to print so and so things. That is, this was happening initially, but then this has to stop, and then the second task with higher priority should be executed. In this case, whatever the resources were allotted for this would be shared to this task. Okay, so yeah, all these concepts are being derived from our operation systems subject. So make sure that you have some knowledge about it. Okay, next we have communication. So in communication, inter-process communication happens. That is, communication between processes happen through like there could be messages sent, or they have shared memory, something like that. So through which a particular process can interact with the other process, and that's how they can maintain the like they can be synchronized in the system. Okay, so this was about the single processors. We have multiple processors under static interactions. So multiple processors have parallel execution, right? So multiple processes or threads can run at once on different processors. But static interactions are more complex due to simultaneous execution and potential contention for shared resources. But then coming to multiple processors, here we have multiple processors, and multiple tasks could happen at once. Then we have synchronization issues. Synchronization issues means processors should be synchronized to avoid any conflicts or inconsistencies between the other ongoing processes. Okay, so we can make use of the locks here, or semaphores, all those topics. Okay, then we have load balancing. Load balancing means the total load. If a particular task is given, it has to be divided properly or equally, and then executed further. That is parallel execution. Okay, pipeline, we have studied the pipeline topic. Yeah, then we have communication. Communication is inter-processor communication. So in inter-processor communication, as we have multiple processors here, the different processors can communicate with each other. So this communication could happen through the network or any other process. Then you have the data consistency. So we have to ensure that data consistency across the processors by making sure that the cache coherence and memory consistency are being handled. So in static interactions, many of such includes mechanism for handling the issues like deadlocks and all. But then coming here, there's no such mechanism. Like we do have our lock semaphores and all, but then again it is used only when we have a particular set or a standard set of resources. So data consistency should be overall made sure that it is obeyed. So this was about the key points about multiple processor and single processor. Looking at the differences now, we can say that a single processor is sequential. That is, once it started, then it will keep on going, and next should be followed after it is one task is executed. Coming to multiple, it is parallel. So multiple, a particular task could be split into certain smaller loads, and then it could be executed simultaneously. Then we have the complexity. So firstly, we spoke of the execution, how execution works. Then we'll speak of the complexity. Then we have the performance. Speaking of the complexity, we can say that single processors have simple complexity. They are simple, okay, simple interactions, easy to understand. But then multiple are complex because parallel execution is happening, multiple resources, multiple resource sharing is happening, and all of that. Then we have performance. If we speak of performance, we can say that the single processors have limited performance, but then coming to multiple processor, the performance is high here because the tasks are being completed quickly, resources are efficiently used, and all of that. So this was about the static interaction in single processor and multiple processors. In exam, they can also ask the dynamic interaction for single processors and multiple processors. The notes would be available in the description for this module, my handwritten notes, and along with this, the PPT, the PDF would also be available. If you have any doubts, do let me know in the comments. And I've tried to cover all the important topics for this particular module. Yeah, so here we reached to an end. If you have any doubts, do let me know, and subscribe to my channel. I have tried covering all the important topics of all the modules, guys. So I would suggest you to go through the important questions which I've published in the G Drive. So make sure you cover all those questions first. Make sure you're thorough with all those questions, and then you can look up to the extra topics whichever are present. So one suggestion, guys, while writing the decision table and all, if you don't know the value also, make sure you write it proper, make sure you fill it properly. And if not the above part, if not the condition part, make sure you fill the action part at least properly. Not just that, when it comes to writing the programs also for first module, third module and all, there are 43 lines of programs which you may not remember at that particular time. So no problem, guys, write anything, but make sure those 43 lines are filled. And it holds the same for program graph, data, dd graph and all. Again, you have to write program for that, the triangle program, and then perform and then draw the graph, right? Yeah, so these are the suggestions which I would give. And all the best for your exam. Yeah, let's get back for the open elective subject. Stay tuned. Thank you.